Can you hear me? Yeah. Good morning, everyone. Well, welcome to the session. And I would like to start by talking about studies. And according to studies, you will trust me and you will think that I am quite smart by the simple fact that I wear glasses. According to studies, you will think that I am knowledgeable, that you can trust me. But we know that studies, we shouldn't look at them and apply them every single time. Otherwise, we wouldn't be here because TDD would be a real thing, something that everyone is using everywhere, because studies have proved that it works. And if we had to trust studies that way, that blindly, it would mean that you couldn't trust yourself to take decisions, because now you think I'm smart by the simple fact that I'm wearing glasses. And that's not the case. You can take your decisions. You came here today, you looked into the agenda, you checked amazing talks, amazing speakers, talks on AI, talks about performance, and you choose test-driven development because, in fact, you want to get good at it. You want to use it. Or did you choose this talk because I'm the only one wearing glasses? We'll never know that. However, one thing I know that studies don't cause change. They don't transform people. But there's something that I really love that change. That is stories. Stories have a power to change every single thing. And you can describe most stories using patterns. Kind of like we use design patterns. When you create a story, you have some convention, some things that you know they will work out. And we can create some shapes to describe them. And usually, we can use something like this. We have an axis that go from P to V, where to N, where P stands for positive value and N stands for negative value. So when things are going wrong. Then we have an axis that is the axis of B to E, where B stands for beginning and E stands for energy. It was Einstein that said that, right? So we know that in the beginning of a story, usually what will happen is that you will have a lot of exciting. And let me map that to a story that most people know. The Lion King by Disney. In The Lion King, in the beginning, Mufasa has his firstborn, Simba. Everyone is super excited. You can see the curve going up. There's a lot of enthusiasm on Simba, and especially because Simba, he wants to be a king. He's confident, he knows what he's doing, until the day that everything goes wrong. And there's a trap by Scar, the bad guy. He wants to catch Mufasa. Worst part, Mufasa dies. Sorry about the spoilers, by the way. Mufasa dies, and Simba runs away. He thinks it was because of him. So he goes away. And this could be just a sad story about a lion. But the reality is that what makes it a great story, a story that we connect, a story that we are addicted to it, is the simple fact that on that moment, Simba will learn new things and will get out of it. He will learn new things and he will come back and will fight Scar. And then, by the end, the kingdom will be even in a better place than when it starts. This is a transformational story. It's a story that you might recognize, for example, from love stories. Let's try with those ones. In the beginning, every single thing is perfect. Every single moment is perfect. We just want to be together. Until the day that we will have some discussions. The person doesn't like our friends, but worst of all, doesn't like Star Wars. So now, what can we do? Should we quit? Maybe. But sometimes, if you stay together, if you try together to work through the problems, and you will go to them together, you build a story of challenges, and after that, you will get in a better place, and hopefully, you will find a love story. So, if most stories, the most transformational stories, work this way, isn't it the case that we can map this shape to learn in TDD? Yes, we can. And that's what we'll be doing here today. Because many times, the reasons why we stop doing TDD is on that valley down there that we stop because things are going wrong. And there are a set of challenges that we need to overcome, and we quit. So I'm here today not to teach you how to write your first test, not to show you a ton of code. I'm here to let you know the problems that you will face, the challenges that you will face, and hopefully give you the tools so you avoid getting stuck there, and that way achieve the transformation that we are looking for. If that sounds good, my name is Gui, and I talk a lot about test-driven development because, in fact, it's something that changed me. And that's the reason why I have so many videos. That's the reason why I have a course. But nothing of that prepares you to the world out there where we have angry snobs using X or Reddit discussing about test-driven development. And in one side, you will have those that will say, TDD is the best thing ever. You just don't get it. The same way that when my dog was just a puppy, I used to say that he couldn't learn new tricks because he just don't get it. Okay? I was putting the shame on him. And it's the same thing that we do. And then on the other side, you'll have those that, yeah, they don't like it at all. They say it's a waste of time. Maybe they never tried it. It's kind of like a preconceived idea. Or they don't write code on the day-to-day, but they know one thing. They know that when they need to deliver code, and developers say that they need some more weeks, at least they can do one thing, right? And if we can skip tests, but now developers want to write tests first, I can skip the code, right? So what can I do? But the worst part in this group is that some, in fact, tried test-driven development, and things went wrong. They found out that, for some reason, tests became hard to maintain. They found out that, for some reason, the tests are coupled to the structure. So now, it's so hard to refactor anything to a point that looks like development takes ages. And takes ages because they are building a ton of tests where some of them are useless, completely useless. So it's natural that those don't like it. They want to skip it. It's something that doesn't work for them. And now is that possible that we have two groups with such opposite views fighting each other? I usually tend to think that when there are two extremes, the truth should lie somewhere in the middle. It can be that black or white. That I think there's something here. So let me tell you my story, my personal story, how I got into TDD. I used to work at a company where we had ambitious deadlines, just to not call it impossible. And being a smart guy, I had deadlines on Fridays, right? That's the proof that wearing glasses doesn't mean anything. So there was one that I have that in my mind, quite clear, crystal clear. And on that one, it was a Friday morning. We thought we could deliver the things, but things were going wrong. We were finding some problems. But we committed to deliver that to the client for the second time after failing the first deadline. So we wanted to really do it. So we decided to stay late that day, order some pizza, and push through it. Called my wife, said, not going home for dinner. She was upset, obviously. It was not that uncommon, to be honest. But we finally did it. And when we did it, we pushed to production, we smoke tested it, looks fine, let's go home. I was leaving the office, walking to my car. It was night, it was cold. The Portuguese cold, not the Norwegian cold, okay? Just let me correct. Looks like, I would say it's Norwegian spring, maybe. So I was going home, and eventually my phone starts ringing. And on that moment, I knew that I was not getting home to relax, but to address yet another problem. And that wouldn't be a huge problem if this didn't happen too often, but it did. Okay? And I tried so many things. I tried unit tests, I tried integration tests, I tried end-to-end tests, and nothing worked. Because when we were in a rush, we would skip them, for sure. And that was something missing, because even the tests that were in place, we often throw them away. So I was looking into my bookshelf, and I had that book there. And I've read it in the past, but it didn't stick to me. I tried it, but it didn't work out. It was quite strange, writing the tests first. But somehow, I decided to pick that book again. But this time, I had a goal of sticking to it at least 6 months. I would be brave enough to be with it for 6 months. And the reality is that during the process, I have learned that TDD wasn't the solution for everything. It's not a silver bullet. But it was something that changed me, that transformed me. And I know that many people that have a lot of experience with TDD will tell you exactly the same, but usually they don't say what changed. My best description is, I don't think I'm one of the best developers. I know a lot of great developers, and I know that I'm not like them, but TDD gave me the habits, the frameworks, the tools to do kind of like a good job, okay? To be almost as good as them. So there's always an opportunity to use a tool that will teach you something. And it was what happened to me. That was my transformational story. I also had that peak of excitement. Things went wrong. I quit several times until the day that I stick to it 6 months, and I finally got it. And it was so hard because getting out of that place where most quit without a mentor is extremely hard. Without someone giving you the hand and saying, come with me. Yeah? This is the type of challenges that you will face. This is what you do to avoid them. So, today this talk is to show you all those things. And if you want to be brave enough to go on that journey, let me tell you what will happen. It will feel strange sometimes. We are not used to write the test first. We are not used to think that way. But we can do it. And it will all start with the famous red-green refactoring. No, it's not a mistake that all the boxes are green. I'm simply aware of the power of suggestion. That is a psychology effect that says that if I show you enough green on the way out, you will take the best decision. If you trust science, you will follow that, okay? So, red-green refactoring. Doesn't it look so simple? Isn't it? Just 3 steps. But the problem with simple things is that often they hide a lot of things. A lot of hidden rules, a lot of small things that if you do it wrong, everything can go wrong. And the worst part is that this thing is incomplete. If you read the books, you will see that even on the first book, the one that I said by Kent Beck, that is kind of like the Bible for the thing, there's a missing step here that is a thinking phase, a moment when you stop and you start thinking, what's the next best thing to do? Because it looks like from this cycle that everything will happen magically, but they will not. So you need to start with a thinking phase, and that thinking phase starts in something that we call a test list. The test list is the place where you will offload every single thing that comes to your mind. Are you in the middle of writing code and an idea comes to mind, like, I want to improve this case, write it down. Do you notice that there's an edge case that needs to be covered, write it down. Because if you start going after every single thing that shows up, like an edge case, eventually you will lose track of what you are doing first. We know that we act that way. So if you stop for a while when a new task comes in, and you read the task, and you write down every single thing that comes to mind, test cases things that can happen, problems, for example, improvements that you notice that you can do, eventually when you need to take the decision, what's the next best step, it will be there. It will be on a simple thing like pen and paper. You can use a notepad, you can use something as simple as this, but if you write every single thing there, it will be quite clear what's the best next thing. And it will be quite clear if you are making progress or not. Does that mean that you need to write all the requirements here? No. It's only the things that you have in your brain, and you think you will remember them in 10 minutes, because you will not. It's proven. You might be familiar with Getting Things Done, a methodology for productivity created by David Allen. David Allen says that our brain is not made to hold things, it's made to process them. And that's true. It's quite hard to hold more than 7 things at the same time and have a clear decision based on that. So that's why, once you start writing these things, you will notice that TDD is in fact getting things done for developers. Is getting things done is you ain't gonna need it, Yagni, and is the KISS, keep it simple. You will see that in action. Because once you have every single thing on that list, you will avoid the trap of not knowing what to do next. You will avoid the trap on starting with a test that will be the most complex. It will be quite clear to you the next step, the small thing that you can do that will keep you moving forward. So now that you know what you need to do next, the following traps will be when you write the first failing test. And the first one is the fact that now that you have a list, you might think that it's quite a good idea to write all those tests first. You will write all the failing tests, now let's try to make them pass. But that is basically waterfall. That is taking every single thing at first and try to do every single thing there. That will not work out. You will not take the advantage of most benefits of TDD by doing so. So you will start fighting your IDE as well. Because when you start writing code, and now your IDE is complaining that something doesn't exist, the code doesn't compile, your IntelliSense doesn't show anything, it will be hard. It will feel so strange to do it. And you might be tempted to go to your code, and now let me create the class. Let me create a method. The method will not do anything, but at least now I can use IntelliSense on the other place. But that is wasting an opportunity for one of the best things of TDD, that is the opportunity to think about how I want other people to use this code. That pain of typing every single thing, that painful thing, is quite informative. So use that as an opportunity. Other things, and by the way, if it doesn't compile, it's still a red test. Don't worry about that. And since we are talking about red tests, there will be a challenge at some point that is you will feel so confident with TDD. And when you write a failing test, seems stupid to run the test to see him failing. You know that the code doesn't exist. But you do this so often that eventually you will not be sure if the test is testing the correct thing. If you don't see it fail, how can you be sure that it works? That's one of the reasons why I'm not a huge fan of testing after. I don't trust things that I've never seen failing, because I don't know if I've written them well in the first place. These are the traps that you need to avoid taking your test to red. Then is the moment to take the test to green. When you try to take the test to green, some things will happen. If you are an experienced developer, eventually you will start trying to burn steps. You'll try to go too far. You know the thing that you want to do, or you are trying to follow TDD in a way that you have seen on an online tutorial where there are a lot of small dumb steps, like I'm summing 2 numbers. Let's write the test for 1 plus 2. So now the first implementation will be just return 3. because it's the sum of 1 plus 2. Now, let's replace that with the variables. Or even worse, let's now add another test case, this time 5 plus 1. And now let's add an if statement that in case the arguments are 5 plus 1, I will return 6. That is just a waste of time. We all know how to sum numbers, right? I think so. So, if it's obvious, just do it, as Nike says. And don't worry about that, because if you know where you are going to, if you have an idea how to achieve that thing, do it. You are not wasting time. You are not going into a dead corner by doing that. It will go fine. Because if it doesn't go, if the tests fail when you are brave enough to try to do the thing right away, once you have the test, you have options. You can always fall back to those dumb steps. The same way that in a race, you might need to change tires depending on the weather conditions. In TDD, we might need to change strategy depending on what the code is telling us. If the tests are failing, we can use another approach. Other thing that will be extremely hard, another challenge, is that we have a lot of experience, we know how to write code, so when I'm implementing the first version, I will have a natural tendency to refactor the code automatically. I will already write methods in the proper place, the classes in the proper place, everything as it should be. But let me tell you a story. I used to work with someone, and for sure you know someone like him, that no one in the team liked to touch his code. Every single line of code was inside of a single method. Names were a mess. No tests, obviously. He was not the type of developer that would like to read books or read blog posts or even coming to a conference like this. It was not his type of thing. We were quite sure that all the code was copied from Stack Overflow. But oddly enough, managers, POs, they loved him. Why? How's that possible if the other developers didn't like him? The reason is quite simple. He was always the first coming up with problems with requirements. He was always the first showing up progress. So I still can't believe that I have this on a conference like NDC, but be a duct tape programmer like him. When you are taking the code from red to green, it's not the moment to write the beautiful code that you like. It's the moment to try to rush every single thing in order to make that test go green. If you need to copy from Stack Overflow, do it. Now it's the moment where I will use AI in this talk. If you need to use GitHub Copilot, do it. Okay? Now this is an AI talk. If you do whatever you can in order to achieve that as soon as possible. Because once you achieve that, all the scenes that are here, all the bad naming, all the code inside of a single method, every single thing will go away in the best stage, that is the refactoring stage. What's your biggest challenge when you face refactoring? Is that it's the last step of the cycle. What we usually do to the last steps of the cycles, we usually skip them, right? Or we usually believe that one day we'll get back to this, okay? If we don't take the opportunity to quickly improve the code in small steps, eventually the refactoring will be so hard to do that you will not do it. And every single small improvement that you do in every single step is a chance to facilitate the next step. The next step will be so much easier. So refactoring is optional, but don't skip it. It's optional in the sense that you might not change anything in your code. You might find that your code is quite good already. But at least look at the code and try to check if there's anything you can do to make that code good. I could come here saying that you should make your code clean, that your code should follow given patterns, that should be solid, that should be whatever. Your code should be maintainable and simple, okay? Just that. It's your goal here. But it's not only your code. Otherwise, you will fall in the other challenge. That is, you don't take care of your tests, and things will go wrong again. If your tests are not easy to read, are not easy to maintain, eventually when you need to evolve them, you're screwed. And your tests are supposed to act as documentation is one of the biggest benefits on test-driven development. But now get ready to the worst of all. The worst of all is this one. Don't add tests here. According to Martin Fowler, it's not me that I'm saying, someone with authority, refactoring doesn't change the external behavior of your application. So there's nothing from the outside, from the user perspective, that should change. The application keeps behaving in the same way. What changes is the internal structure, the internal implementation. That means that you don't have tests. If you don't have new behaviors, you don't have tests. If you respect this, now you know all the dragons that you will need to fight on that cycle. But TDD is not only about those small tests where this thing is clear. You also have other types of tests. So you will start looking into things like this to come up with a good testing strategy that anyone in your team comes to a task and he knows what types of tests need to be written. He knows that he should write a unit test, an integration test, an end-to-end test in a given scenario. But we don't like duplication, right? Duplication is a bad thing. Everyone is saying that for a long time. So we'll start struggling with the fact that we have integration tests that test exactly the same thing with that unit test, but do a bit more. So we'll look online and we'll find some people saying, yeah, ignore that thing of the pyramid, should do a diamond. We like diamonds. So you have more integration tests, less unit tests, but you have the benefit that you have less mocks. And mocks look like, according to them, is a bad thing, okay? And often they are. So this looks like a better way of doing it, but this is the next trap that you will find in your journey to love TDD. Because taking 60 seconds to run a test suite is not a lot unless you practice TDD. When you practice test-driven development, you will run those tests so often that 60 seconds is too much. And if you need to wait 60 seconds to see the results, eventually you stop running them. Or at least you don't run them as often. And if I don't run the tests now, and I do several iterations, okay, and during those iterations I didn't run the tests again, when things finally fail, I don't know on which step I had a problem. So now I don't know what I need to fix. I need to revert several things. And that is part of the biggest benefit of the feedback cycle that you are closing. So let me argue that there's nothing wrong with this. What's wrong with this is naming. But we all know that naming is extremely hard. And one of the names in software development that I think is quite hard is units. No one has a great definition for what a unit test is. I don't have one. But there's someone that has an excellent definition for what a unit test is not. And that person is Michael Feathers. According to Michael Feathers, a unit test is not something that will touch a database, that will go across the network like calling an API, or something that calls your file system. It's not something that depends on the environment, like your machine, like accessing the clock. If you have any of those things, your test will not be a unit test. And that can give you the direction for what you need to do to avoid these traps. Why? If we think about it, one of the reasons why it's so hard to sometimes understand where we need to write the test is the simple fact that we don't have a clear strategy. Okay? We don't know which part of our application we need to test with an unit test, which part of our application we need to test in an integration test, all of that. Lucky of us, there are architectures that are designed with testing in mind. And my favorite one is this one. It's quite simple, but don't worry, it's hexagonal architecture. Don't worry if you prefer clean architecture or you prefer something like onion architecture, whatever, because all of them came from this. Even the authors say that they were inspired by the work of Alistair Cockburn on the hexagonal architecture. And the beauty of hexagonal architecture is that it's so simple that you can apply the principles everywhere. And the principles are quite simple to explain. It says that all the applications have two sides, an internal and an external side. The internal is where all the code, all the magic sauce that you have been building will live. Okay? All the things that you are hired to do. The external is messy, is hard, is unpredictable, is strange, is an HTTP call, is a call to a database, is calling a service somewhere, is sending an email, is anything that goes outside of the boundaries. Isn't that those things the things that make it not a unit test? Yes, they are. That's why this architecture works, because in the way that it is conceived, you will put all of your magic sauce inside of that hexagon. Then you will come up with contracts with the outside world. You will say to the outside world something as simple as, hey, this application can create orders. For that, I need a contract. I have a contract that you can respect, where I will give you an object of an order, and please use that object to save it somewhere. That's my contract. It can be an interface, something like that. Then someone will come and will write an adapter. That someone might be us as well. And we'll write an adapter. That adapter has a single role that is translating that contract into something. For example, if the contract has the object of the order, I will translate that into an insert statement into SQL, and it's done. It's the only goal. It's quite thin. The same way that our applications need to react to something. We need to expose that to somewhere. So we also need ports that are contracts saying things like, hey, I can create orders. If you want to create an order, please send me this object. In return, I will give you an ID, for example. So now I can create an API, I can create an UI, I can create a command line, or even I can react to a message. And I will write that once again as a thin layer, in a way that most code will still be in the center of my application. If we keep this in mind, now we can translate this into a proper strategy, because we can map the architecture into a testing strategy. So we know that in the center of our application, we don't have any of those unpredictable things. Everything can be a unit test. But in the adapters, it leaves all those things that are strange. So the integration tests can be as simple as starting like a container with a database, and we call that adapter to check if we can communicate with him. But we all know the meme that we have the unit and we have another type of test, and they don't match together, right? That's why we'll have those end-to-end tests. I like to call them application or system tests that are kind of like a smoke test, just to make sure that everything is wired up correctly. And how is that related to TDD? Oh, because the natural tendency once you are in your journey, your hero journey through TDD, is that you'll try to apply it everywhere. But TDD works quite well on that core application, that hexagon. It's perfect for unit tests. Integration tests, we can argue about that. But when you touch things like an UI, for example, driving the user experience, when you try to build something like a spike, TDD is not the tool for that. It's an excellent tool, but it's not a tool for everything. Do you have to come up with a conclusion if we can do this type of thing in just a few days to say to our clients how much it will cost? You don't need TDD for those things. Okay? So, with this in mind, now you have a clear picture. And even then, if you don't practice TDD in all of those things, you might need to do something that we call acceptance test-driven development. Acceptance test-driven development is a practice that basically says that you will sit down with your clients together, you will write a set of requirements, okay? But in the end, you are building a DSL so your client can write the test for himself. It's a lovely idea. It's perfect. It will remove work from us, but almost never works. The clients don't write those tests, or if they write them in the first time, it will be with your help, and eventually it will be you maintaining that. And the problem with that is that you have been building a DSL so they can write tests like, given a new client when is authenticated, and I want a new order of a product X, I want to apply the discount of 5%, something like this. And now you need to have a translation layer to convert that into a proper test, something that will be executed. So you will keep maintaining a translation layer for a DSL that is translating to something that you know how to write and how to read. So on that case, if you need to use a TDD as a way to show to your client that the code is doing what it's supposed to do it in your own language. Do you use C#? Use C#. Do you use Java? Use Java. Whatever. Next challenge. Once you do every single thing, you are so excited because your coverage is so high. You have been test driving everything. You have tests for everything. But even then, it will not be 100%. Right? So let's set a target. Let's have a goal to have test coverage of 90%. Let's set a goal of having test coverage of 100%. Why not? Let's be ambitious. The problem is that if once you start doing that, what will happen is that you will write a ton of useless tests. Tests that don't check anything worthwhile. You are just writing tests for the sake of writing tests. One thing I have learned during my career is that once you give a goal to developers, they will find a way to achieve it. Doesn't matter how. Does it bring value? I don't know. But they will achieve it. So what you should do instead is to treat coverage, code coverage, as a metric instead of a goal. You should look at code coverage as a way to understand how your tests are going. Are you missing some places? But they will not tell if the tests are good. If you want to really assess the quality of your code, what you need to do is to have something that will tell you how many bugs do you have. Are they increasing? Are they decreasing? What's the lead time? How many hours do we take from beginning to the end of a task? And also, an excellent tool is using mutation testing. Mutation testing is a practice that will check the quality of your tests indeed. While coverage only checks if the code was executed by a test, mutation testing can check if, in fact, you are asserting that the code does what it's supposed to do. But don't use that as a goal, replacing the other one. Use that as a learning tool, because mutation testing can inform you the types of cases that usually you ignore, the type of cases that you usually don't test. It's an excellent tool to have in your stack. And even following all of that, you will be so happy. You now mastered the cycle. You now have all those tests perfect. You now know how to use mutation testing. And everything is going well. So you are fighting those dragons. But there will be a moment, there will in fact be a moment where everything will go bad. Mufasa will die. And that moment is when you are refactoring something and you are so confident because you are TDD, you are practicing TDD, and even then, most of your tests will fail. And you need to throw them away. And this, my friends, is when you quit test-driven development. Most people quit test-driven development right here. And why does that happen? That happens for a single reason. We are so used to write the tests first, the tests after, that changing our mind that the reason to create a new test is not when we have a new method will be hard to get. That's absolutely false. What you should do instead is to have a new test every single time you have a new behavior. Let me give you an example. Let's pretend that we have this case. We have a test that is checking an order management that is creating an order. So we now know that the first approach when we take from red to green is to simply write every single thing in a single method, right? Eventually, you will refactor it. Now we are refactoring. So we extract the part that will validate the order to a different method, kind of like an internal method. So we'll test that. But that is another problem waiting to happen, because now you couple your test to the structure of the code. That's why, unless you are in a rare case, you don't test internals. Otherwise, it will be so hard to refactor. But now you might say, OK, I will not extract it as an internal method. What I will do instead is that I will extract it as a different class. OK, sounds good. And let's test that class. Now that the class is tested, I have a question that I need to answer. The class on top, the order management, still needs to use the order validation. So how do I do that? And typically what we do is that we will extract an interface from the order validator. And then, for the test on top, we'll mock it. Okay? Now we need to program expectations like saying, hey, when I'm running this test, please consider that if you receive this object, you should return that it's valid. Something like that. And now you start abusing from mocks and interfaces. You start having interfaces just for the sake of testing. That's not the goal of interfaces. And worse is that you have a ton of mocks that you need to program expectations. And those tend to be quite fragile in the middle of a refactoring. So what you should do instead? How do you know if you should have a mock or not? Because there's still places for mocks. So to know that, there's a really complex flowchart that I will explain you. And the flowchart starts this way. If that class will make the tests flaky, slow, or unstable, you have one option that is creating a test double. A mock is a test double. There's other shapes of test doubles as well. And the other part of this complex workflow, and get ready because this will be hard, if it's not, use the real thing. If that validator doesn't touch a database, doesn't go across the network, doesn't touch your file system, doesn't make your tests flaky, and slow, or unstable, you can use the real one. That way, you can be sure that when you refactor the code, it will not break. You are still testing the behaviors, the original behaviors. So if we translate again into our example, that would mean that instead of using that as a mock, we can use our real validator. And it will be perfectly fine, with the advantage that we have fewer tests, and they are quite stable. We are still testing the outside behavior. And this is what, if you remember, is exactly what Michael, Mr. Fowler, was saying. He says that the only reason to have a new test is when you have a change in the external behavior of your application. Otherwise, it's just an implementation detail. What if that order management, after validating the order, needs to touch a database? That is the case where you introduce a test double. That's the thing that you need to mock. But this is still a unit test, even having a class calling another class. That's still a unit test. And this way, you can avoid breaking your tests at any given point without knowing why. This way, you can safely refactor. I promise that. By knowing all of that, what I'm saying is that we need to test behaviors instead of testing implementation details. Why? Behaviors can be tested through the public contract. The public contract is those edges of that hexagon that I told you. You just need to cover that thing, that box. You don't need a lot of tests for that. And why that's beneficial? For a simple reason. The contracts are stable. Contracts are not supposed to change a lot. While the implementation details, they change and we are supposed to be able to change them without thinking about that. That's the idea. Just as a practice, and to help me out, I would like to do a small exercise, if you don't mind. Can I ask for a round of applause? Thank you. Don't leave the room yet, okay? So we will go for a few more minutes. Have you noticed that I didn't ask you for applause with this given frequency, this loud, this number of claps? I didn't tell you who should start, who should finish. I told you one simple thing, that it was the what instead of the how. And when you are in doubt writing a test, just think about the applause example. If I came here and I said, you should start, you should finish, please everyone clap 3 times with a frequency of 0.2 seconds, we would fail, okay? This would be a mess. And I achieved the same goal, so why doing it? And when you start thinking about the tests that you write, when you use mocks, when you have so many classes and all of that, often they are checking things like, I call this method once, I call this method twice, I didn't touch that method. That is checking the how, is checking the implementation details, and that is not the goal. The goal is to testing from the outside, and if someone was here closing the eyes, they knew that there was an applause. That was what I was expecting. By knowing all of that, I promise you that alone you can do it, but once you get back to work, everyone will say, TDD will slow us down. And how can you answer that? This is one of the final dragons that you need to fight. You are like Frodo getting back home, but you still need to fight some dragons. The way to fight that is by saying this. According to Cambridge, 50% of the time that you spend in a programming session is debugging. 50%. According to Clockwise, that is an application to track the time that we spend on our computers, they have done some research and they came to the conclusion that developers tend to spend 11 hours of meetings per week. That sounds too little to me, to be honest. And they also say that there's 6 hours more that we spend between things, like between meetings, between tasks, okay? So that leaves us with 23 hours of focus time per week. What means that 11.5 hours are debugging, addressing problems. And one thing that I can promise you is that if you practice TDD, those 11.5 can come back, because you will rarely touch your debugger. The number of problems will decrease. And even if then they don't trust you, they don't want you to do test-driven development, let me tell you that you can do it alone. I had the experience of working in teams where I was the only one practicing it. So instead of asking for permission, just do it. Think like I have done. I think that I am a better developer. I do a better job to my company if I do it this way. So use the tools that you have. Use the things that you have learned. Don't be afraid of that. Because I promise you that you will find something special on TDD, is that TDD behaves like a flywheel. A flywheel is a mechanical device that conserves momentum energy. That means that once you put it spinning, it will keep spinning without investing a lot. In the beginning, it will be quite hard, but then it will be so pleasant to work. It's like test-driven development. In the beginning, it's quite hard. It takes more time, for sure. But then everything will come without a lot of effort. You will write the first tests. They will be hard. You will improve the first classes. It will be extremely hard. Eventually, someone will notice that you are doing things that way, and they want to join you. They want to learn with you. And eventually, you will start realizing that the number of bugs created by your clients starts decreasing. If the number of bugs starts decreasing because you have a lot of tests in place and you don't have as many regressions, what will happen is that you spend more time working on new features. And now your client is so happy. He doesn't complain as much. He has the things that he wants. So who's happy as well? Your product team and your manager. Your manager has a bonus for you. Isn't that cool? But better than that is that he gets a bonus even bigger than the one that you are getting. So everyone is happy. That's the idea of the flywheel. And that will happen. And once you see that happening, what I can promise is that you will have a feeling that it's kind of like an infection. It's like you can't do things in the other way around. But on that moment, keep in mind every single thing that you have learned during your journey, because that can lead you to try to use TDD where it's not supposed to. That will take you to that famous curve. You are finally getting out of it. You are finally finding the success. You are finally getting in love with it. But when we achieve success like this, there's one important thing missing. And let me get back to the story of my talk. His name is feijão. It's the Portuguese word for bean. So it's a black bean, as you can see. When he was just a puppy, taking him for a walk was a nightmare. He would pull the leash, he would run, bark, try to hunt butterflies. He would jump everywhere, he would try to eat poop. Dogs do that thing, sadly. And it was an absolute nightmare. Until the day that I decided to ask for help. I asked for help to a dog behavioral specialist. Those things exist. Yeah? And in a single class, in a single session, everything changed. It was night and day. It looked like a different talk. But the reality is that it didn't change. What changed was me. Because I learned that to teach, I need to first to listen, I need to observe, I need to have empathy. And that teach me so much during these years. I lost him a few months ago to cancer. And until the last day, he made me a better teacher. What I want to say with that is once you go out there, and if you master a tool like TDD or another one, have empathy with others and don't say, you just don't get it. Thank you e obrigado. If you have any other questions, please come up. I will be here, okay? And have a great conference.